Okay, this is section 3.6. Section 3.6 is about logarithmic functions and their derivatives. So we have two parts here. Part A is actually logarithmic functions and their derivatives. So we're going to deal with functions like this. We have y equals log base 2 of x, y equals ln of x, y equals log base 10 of quantity x squared plus 1, y equals ln of sine of x. In all cases, what we want is to find the derivative of these functions. So these are logarithmic functions, and we want to know how to find their derivatives. So we're going to start with a general case, which is y equals log base a of x, and we're assuming a is not e. E is a real number that is about 2.718 and then continues. Okay, so we're saying this base a is not e. So we want to find y prime, or we can write dy dx. So this is a solution that kind of generates the formula of finding the derivative of y equals log of x base a. So you know from your pre-calculus course, there is a connection between a logarithmic function and its related exponential function. To change this logarithmic function to exponential function, we have to take the base a, raise it to y equals x. So base a raised to the other side, which is y, equals to the entry of log, which is x. So it gives you x equals a to the y. So that's the exponential form of this logarithmic function with respect to the pre-calculus course. We also know that if you take the derivative of a to the x, it gives you a to the x times ln of a. We did this on the past section. So what we're going to do basically, if we go back here, we're going to ddx this equation. We're going to take the derivative with respect to x of this equation. I think PDF kind of delete this here. So we ddx the equation. We put ddx to the left and then ddx to the right of the equation. Now the derivative with respect to x of x is 1. Derivative with respect to x of a to the y. Here we're going to basically apply the chain rule. So you're going to take a to the y. So it's going to be a to the y times ln of a, and then times dy dx, because you're taking the derivative with respect to x of a y term. And then y is a function of x. So you have to put the dy dx because of the chain rule. And then from here, from this equation, since we're looking for dy dx, then you can solve this equation for dy dx by dividing both sides by a to the y times ln of x. So then you get dy dx. Now, so what does it tell us? We get 1 over a to the y times ln of a. But we know the expression of a to the y. We have that expression here on the first slide. So the expression of a to the y is actually x. So we'll have to go and replace a to the y by x. So then the formula becomes 1 over x times ln of a, which is the derivative of log base a of x. So you get the formula. We can write it also as ddx of log of x base a, which is 1 over x times ln of a. So next we do some examples. For example, if you are given y equals log of x base 10, and you want to find the derivative, so the derivative is going to be 1 over x times ln of 10, because the base a is 10. Now this is the remember this function at the beginning, we want to find its derivative. So this time we don't have x, a single x here. We have sine of x. So we have to treat this different from what we did. So let's just generalize this for a second. We're going to generalize this as y equals log of a g of x base a. So we're calling sine of x as a function of x, g of x. Okay? So if we have something like this, what then its derivative? So when you take the derivative of this, what happens is log base a is an outer function, g of x is the inner function. So here we're going to apply the chain rule. First, you're going to take the derivative of log base a, and then you're going to evaluate it at g of x. So the derivative of log base a is 1 over g of x times ln of a. Okay. So, and then at times, the chain rule says to take the derivative of the inner function, so g prime of x. So we can rewrite this, kind of make it look, it's like, so you have 1 over g of x times ln of a. The whole thing is multiplied by g prime of x. In our case, for this case, the base a is 2. The function g of x is sine of x. So since we see g prime of x, so we will need to take the derivative of sine of x, which is cosine of x. So that's why we're going to end up with 1 over sine of x times ln of 2, and then times the derivative of sine of x. The derivative of sine of x is cosine of x. Then we want to use trigonometry here. We know cosine of x divided by sine of x is cotangent of x. So after multiplying 1 by cosine of x, we get cosine of x over sine of x times ln of a. Cosine of x over sine of x is cotangent of x, when divided by ln of 2. So that is the answer for that. Okay, so I'm going to stop the video here. Thank you.